So in this video, we're going to talk about squeeze theorem, what it is, and then I'm going to give you an example. The theorem is if on an open interval I containing a, so this is some x value, we have that f of x is less than or equal to g of x is less than or equal to h of x for all x and I. So this little symbol here just means in. And if we have that the limit of f of x is equal to the limit of h of x, which is both are equal to L, so these two sides have the same limit as x goes to a, then basically g of x is going to have the same limit, essentially because it gets squeezed in between f of x and h of x. And so graphically, this might make a lot more sense. So basically, we have this function h of x and this function f of x. And g of x is squeezed right in between them. And so if h of x and f of x meet up at this point A and they have the same limit, then g of x has to go there as well. There's basically no other place that g of x can go except for at this point, because otherwise it would contradict this inequality. Okay, so I'm going to show you how you could use something like this to solve a problem. So we've got evaluate the limit as x goes to 0 of x times sine of 1 over x. Now, you might initially think, well, why don't I just plug 0 in? I've got 0 times sine of, and then here's the issue. We get 1 over 0, which is undefined. It's not a number. It could be, we don't know. It's not a number. So we can't just plug it in. But we do know an inequality involving sine of anything. We know that sine of theta is bounded between -1 and 1. And we could let theta be this 1 over x. And since we're talking about a limit, we're not plugging in exactly 0. We're plugging in numbers very, very close to 0. So we've got sine of 1 over x must also be between -1 and 1, and since we're not identically dividing by 0 here, we're taking sine of actual numbers. And then I can use this inequality and multiply all sides by x. So I've got a -x less than or equal to x sine of 1 over x less than or equal to 1 times x gives me x. And now I can notice that, hey, if I take the limit as x goes to 0 of -x, that's actually equal to the limit as x goes to 0 of positive x. Both of those are equal to 0. Therefore, the limit as x goes to 0 of x times sine of 1 over x must also be 0 by squeeze theorem.